Audio Jungle. Audio Jungle.
All right, now this is the first problem of normal shock. So problem 1, normal shock. In GATE or any one day exam, they are asking question, okay, from normal shock. So the question is, if the flow Mach number if the flow Mach number, comma, pressure and temperature and top temperature ahead of a normal shock are 2.0, 0.5 atm and 300 respectively. Yes or no? Determine 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 M2, P2 and T2, okay, and V2, okay, and V2 behind the shock, V2 behind the shock. So this type of question they are asking. So one property they will ask here, many properties like M2, P2, T2, V2 they had asked. But in real problem, suppose one day or GATE exam, they will ask, so at least one or two value they will ask. They will not ask more numbers. In short, they will ask, okay. So this is the problem actually. All right, now we'll draw one normal shock. See, this is the normal shock, you can say. This is the normal shock. Why it is called normal shock? Because it is perpendicular to the flow. It is formed perpendicular to the flow. So where will be the flow? It will be just perpendicular of it. This is the flow now. So you can say ahead and behind, okay. Ahead and behind value they have given. You just say this is M1. Just say this is P1. This is T1. In fact, this is V1. Similarly, this will be M2, P2, T2 and V. All right. This is what normal shock. This is normal shock. All right. Now we'll go for the calculation. So here you can check the given data. If you check here, what are the given data? Let me write here better. So given ahead value, that's Mach number of the ahead of a normal shock, that value they have given 2.0, means M1 is given. 0.5 atm, which is nothing but T1. Okay, next it is 300 Kelvin, which is nothing but temperature. 300 Kelvin. Okay, it is not mentioned, but you can assume as fluid is a air. Okay, because gamma required. If some suppose they have not mentioned gamma value or they have not given any data, then you can consider it is air. So for air, you should know what is the gamma, because gamma will be 1.4 for the air. Okay, this is the assumed value. Right. So now for this, if you want to calculate the value of P1, P2, T2, M2, everything, then you have to go with the formula, right? You have the formula, all the formula we already have seen last session, we had derived. So we'll start from the M1 M2 relation. Okay, so we'll get first, right, calculation of M2. Okay, what is the relation between M1 and M2? We all know, right? What is the relation between M1 and M2? That formula, if you know, then you can directly start and you can calculate the value. Okay, so I'll write the formula. You already have seen that derivation last class. Okay, derivation you already have seen for M1 and M2, but you need to remember that formula. Okay, anyhow that formula should be remembered. So what is the formula? Formula is M2 square is equal to 2 plus gamma minus 1 M1 square. Okay, divided by 2 gamma M1 square minus gamma minus 1. Yes or no? This is the formula. You all have a value of M1. You keep all the value, calculate this. So what you will get? What is the M1? I think 2, right? 2. So 2 square divided by 2 gamma 1.4 M1 2 square minus. Okay, we'll do this. So this is 2 square. So to calculate this value, so what will be the M2? M2 will be 0.7. So M2 will be 0.577. So this is the value of M2. Now we'll go for the calculation of P2. We all know relation between P1 and P2 across normal shock. Yes or no? We all know. Write formula here. That formula is nothing but P2 by P1 is equal to 1 plus 2 gamma upon gamma plus 1 M square minus 1. Yes or no? So here if you calculate this value P2 by P1, so it is 1 plus 2 1.4 divided by 1.4 plus 1. Okay, and m1 is 2 square minus 1. So if you calculate this value p2 here, p1 is already given. Okay, if you do the calculation, then what value of p2 you will get? Check that. p2 you will get 2.250 atm. p1 they have given 0.5 atm, right? Okay, p1 they have given. What is the value of p1? 0.5 atm. Take this value. Okay, it is given in the problem. Next value you will go for the calculation of t2. Okay, calculation of t2. Okay, we all know the formula of t1 t2 by t1. We have to use that. T1 t2 relation we know, yes or no? So it is nothing but across the normal shock t2 by t1 is equal to 1 plus 2 gamma upon gamma plus 1 m square minus 1, which is nothing but p2 by p1 into rho 1 by rho 2, which is nothing but 2 plus gamma minus 1. It's all the formula we have seen the derivation last class. Okay, so there should not be any problem now. If you keep the value of m1 here, which is nothing but 2, so t2 by t1 you will able to calculate, yes or no? So what will be the value of t2 here? What I am getting, 506.1. This is the value of t2. This is the value of t2. Keep the value of m1, which is nothing but 2, gamma value is 1.4. Do the calculation, you will get 506.1. Okay, now we will go for the calculation of v2. So for v2 we should know, in fact if you want to calculate v1 also, it is possible to calculate v1 also, but for v2 how to do that? Okay, so here you can write next calculation of v2, right? How do they do this? Simple. We know what is the Mach number. Mach number is, what is the Mach number? m2 is equal to v2 divided by a2. What is the v2? You need to calculate what is the a2, which is speed of sound, gamma or p2. Yes or no? Now if you want to calculate v2, then it will be m2 root of gamma or p2. What is the m2? Just now you have calculated, it is 0.577. It is 0.577 root of gamma, it is 1.4 for the air, r is the 287 for the air, p2 just now you have calculated 506. Do the calculation. So this value is nothing but 260. I can write meter per second. It is in decimal 260 point something, but I am writing 260. Okay, this is the one way to write. Another method also I will tell you. What is the another method? We know continuity equation across normal shock. Okay, What is that? Rho 1 V1 is equal to rho 2 V2. So what is V2 by V1? V2 by V1 is nothing but rho 1 by rho 2. If you remember rho 1 by rho 2 value, I had derived this formula rho 1 by rho 2. What was that? It was 2 plus gamma minus 1 m1 square divided by gamma plus 1 m1 square. So if you know V1, then you can calculate V2 by, I mean V2 you can calculate if you know V1 here. So we will calculate V1 also. So this value, okay, take this. Alright, so calculate this value, how much V2 by V1 ratio we are getting. Now how to get V1? How to get V1? So this is nothing but 0.375. How to get V1? We know M1 is equal to V1 divided by root of gamma RT1. What is the V1? It is M1 root of gamma RT1. All the value they have given. If you see M1 they have given, gamma is there, R is there. T1 is the temperature which is given already, 300 Kelvin. If you do that, it is nothing but approximate 694 meter per second, which is the supersonic. Yes or no? So here also you can get V2, which is nothing but 0.375 into V1 is nothing but 694. If you calculate this, check what value you are getting. It is 260.3 meter per second. Take this V2 and this V2. It's same almost. No? So this is the cross check actually. Okay, done. So this is the problem, first problem for the normal shock. All right. This is the problem number 4. A re-entry vehicle, okay, which is also called RV, re-entry vehicle, is at an altitude of 15 kilometer and has a velocity of 1850 meter per second. Okay, a bow shock. I will tell you what is the bow shock. A bow shock wave envelops the RV, okay, neglecting dissociation determine the static pressure, temperature and and stagnation. Pressure and temperature. Just behind the shock. Just behind the shock wave. On the RV center means re-entry vehicles center line. Center line where the shock wave may be treated shock wave may be treated as a normal shock. Okay, assume the air behave as perfect gas with gamma is 1.4 of air, R is 287 joule per kg. So here they have mentioned this is the re-entry vehicle. Okay, re-entry vehicle, and obviously, and it is at 15 km altitude, so that velocity will be very high because it's a re-entry vehicle and it is coming from space to that ground is coming. A shock wave envelops the re-entry vehicle. Neglecting dissociation means because of this high velocity that that medium which is air, that it is not going to change the property, because with very high pressure and temperature, with high velocity, that properties will be changing, but it is saying like just when CPCV all are constant, that's the mean of it. Okay, determine the static pressure, temperature, and stagnation. So here they are asking static pressure, temperature, right? So at 15 km altitude, first you should know what is the pressure, temperature, and density if it is required. Okay, so that one thing you need to calculate first. At 15 km, what is the altitude? What is the at 15 km altitude? What is the pressure, temperature, and density? Static. That value you can calculate easily because it's a stratosphere, and that value you can calculate. You have to calculate, in fact, stagnation pressure, stagnation temperature just behind the shock wave. Okay, center line where the shock wave may be treated as normal shock. Okay, so first I will show you what is the bow shock, and that bow shock center line to the RV, that bow shock will be treated as a normal shock. And they have said here the air, it is behave as a perfect gas, there is no dissociation, so it will be treated as a perfect gas. And for the perfect gas or air, that value they have given to us. All right, now you see, check, we can say it's a re-entry vehicle, so obviously this is the ground station where it is going to return back. Okay, now you can say that re-entry vehicle, if you check, it will be the shape will be like this. The shape will be like this. Okay, so the point is Okay, this is the re-entry vehicle. Okay, so the point is like the re-entry vehicle, that shape is not a sharp corner. It is not like this. It is like, it is not like this. It is like what? That blunt shape, like this. Try to understand. This is the blunt shape. Okay, so this is the blunt shape, and this is what sharp. Okay, if it is sharp corner, then because it is a re-entry vehicle, obviously it is a space shuttle, you can say, so it is having a very high speed. So you have seen that is speed 1850 meter per second, which is hypersonic. Yes or no? So shock will be formed. There is no doubt about it. If it is like sharp corner, then shock will be oblique shock. I told you that last session. This is the oblique shock here. Okay, it will be oblique shock. But if it is the blunt shape, then shock will be bow shock, like this. This shock, what we have here, this is the oblique shock. Okay, and it is also called, it is also attached shock. Attached shock. Okay, this is the object, space shuttle. Okay, or re-entry vehicle. This is the re-entry vehicle. This is the bow shock. Why it is called bow shock? Because its shape is bow, you know, like arrow and bow. So this is the bow shock, right? And this is detached shock. So whenever, if you go and check the space shuttle, or that re-entry vehicle, or in fact that rocket, if it is for mission it is going, then that's that if you check the face will be the blunt shape. Okay, it is not a sharp, because if it is sharp corner, then it will be having a attached shock, which is oblique shock. So why you are making blunt shape for the space shuttle, or any uh, for any mission, if you check the rocket, so that shape face will be a blunt shape. Why? Because you want to be a shock, or actually because of the velocity, that shock is will be formed, that is true, but you want shock, but it's, if it is detached shock, then it will give benefit to you. What is the benefit? The benefit is, suppose this is the, suppose the vehicle which is coming towards the ground with very high speed. So now the air, if you check, the is, this is the oblique shock, and this is the surface of the shuttle, you can say, or vehicle. So here you are getting very less space for the air, and in fact, number one, number two, that shock is what attached to the corner, and if shock will be formed, then pressure, temperature, density, everything rise. So at that time, very high pressure and very high temperature may damage the surface of the vehicle. You understood? So that's the reason we don't want the sharp corner. Sorry. Okay. What I was saying, it is attached shock. If you do this type of shape, then the shock will be attached and it will be oblique shock. So because of very high pressure and temperature, because the air, for the air, that is space between the shock and surface is very less, so it will transfer more heat and energy, thermal energy, to the surface of the vehicle. Okay, so it will transfer more heat, thermal energy, to the surface of the vehicle, then it may damage, no? But if you are making a blunt shape here, so this bow shock will be formed, and first thing, this bow shock is the detached shock, means there will be gap. See, we have a gap here. Okay, we have a gap, more gap we have now. Number one. Number two, it is detached shock, so it is not directly connecting with the surface of the vehicle. Second point. Third point, because of the gap between the shock and the surface of the vehicle, the air will get more space, so that thermal conduction will be there, but because of the more space from shock to surface, that transfer of heat to the vehicle will be less compared to the attached shock. If transfer of heat to the surface will be less, it means thermal energy from this shock formation, what I am saying here, so pressure and temperature will be rise, that is correct. Here also pressure and temperature will rise because of the both shock, but you are getting the space between shock and surface, so the thermal energy what it is transferring, that conduction will be less. Okay, less in the sense comparatively it will be less comparatively to attached shock. This discharge shock, the transfer of heat to the surface of vehicle will be less, so you can avoid the damage. It is also, the term is given aerodynamic heating, so you can avoid that or you can minimize that. Technically hope you it is clear to all. So here you can say aerodynamics heating will be more. I will give this term in this case. Okay, in this case aerodynamics heating will be more. And here heating less. So this is the reason you are giving blunt face to the space shuttle, so bow shock will be formed. So actually this bow shock will help, because this is genuine thing, like supersonic speed will be there, you cannot compromise with that for the space shuttle or rocket. Supersonic hypersonic speed will be there, you cannot compromise with that. And you know that if supersonic flow will be there, then shock will form, definitely it will form, and that you cannot avoid. Shock will form, but the intensity of the changing of thermodynamics properties you can reduce. How? By giving this shape. If you are giving this shape, blunt shape, then instead of normal shock or instead of oblique shock, bow shock will be formed. If bow shock will be formed, then more space you will get after the shock and surface, more space you will get. So whatever the thermal conduction, that means actually that conduction in the sense whatever the transfer of heat from air to the surface, you can reduce that. Okay, you can minimize that. You cannot avoid, but you can minimize, so that benefit you will get of it. Okay, hope you understood. So in this problem what they are saying, they are saying this space re-entry vehicle which is at 15 kilometer altitude, so it is at 15 kilometer altitude. Okay, so here you should know the pressure, the static pressure value, temperature value, and density value, stratosphere, that you should know. Number one. Number two, because it is bow shock, it is blunt shape, railway vehicle having a blunt shape, so here bow shock will be formed. And in fact, in the problem they have mentioned also, bow shock is what formed. Okay. In the problem itself, they said bow shock will be formed. So okay, they said in the problem itself, center line to the railway vehicle. This is the center line, you can say. Okay, this is what center line. Center line of RVC, it is mentioned. Center line. So where the shock we have, where the shock wave may be treated as normal shock. So the center line means here the shock will be treated as this portion. It is treated as normal shock, because if you take one curve, so if you take a small length, then it will be treated as a straight line. Yes or no? So this is nothing but treated as normal shock. Okay. Hope you understood. Now, so the problem now it is like this. See, this is what bore shock. Okay. This is the center line. So this center line here, it will be treated as normal shock. This will be treated as normal shock. Here the static pressure, temperature, density and velocity they have given to us. What they have given, check. 1850 meter per second. At 15 kilometer you can calculate the pressure, temperature and density. That's all. This value they have given to us. So the velocity they have given 1850 meter per second. At 15 kilometer altitude, this is static pressure. At 15 kilometer altitude, this pressure, temperature and density you can calculate. Okay. What will be the pressure at 15 kilometer altitude? You can write 1.21, okay, into 10 power 4 Newton per meter square. This is the stratosphere. 15 kilometer is the stratosphere. Okay, you calculate this value, stratosphere. Already in atmosphere chapter I had explained well. Minus 56.5 degrees Celsius, convert it into Kelvin, so it is 216 point. This value is what at 11 kilometer altitude, but it is a stratosphere, so at 15 kilometer altitude also the temperature will be same, 260. And density is required. They have asked density or not? They have asked static pressure and temperature. The density they have not asked. If you want you can write, otherwise you leave it, no issue. Now up behind the shock they are asking, so you just say this is the P1, P1, V1, and behind the shock they are asking P2, P2, okay. And obviously another value what they had asked, they had asked temperature just behind, stagnation pressure and temperature just behind the shock. Stagnation pressure and temperature, it means stagnation pressure will be P0 2 and P0. This is the problem. So now it is very clear. You can assume this is the normal shock and then you start solving the problem. Okay. So before going to this, you calculate first Mach number M1. If you know, then you can start your problem easily. No? This is what, check. Okay. What is the M1? M1 is nothing but V1 divided by A1. So V1 divided by root of gamma or T1. V1 they have given 1850. They have said air treated as a perfect value, so gamma 1.4 given, 287. You have calculated at 15 kilometer altitude, temperature is 216.5. If you solve this and if you check what value you may get after solving this, 6.27. See, 6.27. This is the value. Calculate and check the value. So you can check this 16.27 is what? It's a hypersonic. Yes or no? So M1 you know, all right. If you want to calculate P2, then simple. What is the formula for that? Now, all the formulation you check normal shock. P2 by P1 is 1 plus 2 gamma upon gamma plus 1 in bracket M1 square minus 1. If you do this, then you will get the P2. Check this. Check this value. P2 you will get. Okay. Calculate it. What is the value of P2 or P2 by P1? If you check, P2 by P1 will be what? It's a 45.7. Now if you calculate P2, P1 you have written here how much? 1.21 into 10 power 4. If you solve this, then you will get 5.53 into 10 power 5 past 4. T2 by T1. What is the T2 by T1? Check the formula. T2 by T1, you know the formula. It is nothing but T2 by T1. It is 1 plus 2 gamma upon gamma plus 1 M1 square minus 1 into rho 1 by rho 2, which is nothing but 2 plus gamma minus 1 M1 square divided by okay. You know M1 is equal to what you have calculated 6.27. 6.27. What is the gamma value? 1.4. Calculate P2 by T1. It is nothing but 8.58. What will be T2? Check. 8.58 into T1 you have seen here at 15 km altitude, it is 216.5. If you do this, check what is the T2. Quick, what is the T2? So here we are having 1860 Kelvin, a huge amount. This is the huge amount, and you can imagine the intensity of the thermal energy with this temperature. So if it is attached shock, then it will damage more and more, okay, surface of the vehicle. But we are having a detached shock here. Both shock is formed, and it is detached shock. So between the shock and surface of the vehicle, we have a air, and that air you know very well. It will air is what? Air is the insulator, right? So that thermal energy will transfer to the surface of vehicle, but it will be not that intensity, not that amount, because air will be treated as an insulator, so it will try to insulate the surface. All right, but heat will be transferred. Anyway, this is what temperature. Now what they are asking here, they are asking, right, they are asking P2, T2, P02 and P02. All right, so how to get P02 and this P02? So that property of the shock I will tell you. Already I have told you that property we have to use. We know before the shock and after the shock, the flow is isentropic. Yes or no? The flow is isentropic. So if the flow is isentropic, then we can apply isentropic relation. Yes or no? we can apply that. Flow is isentropic, so we can write the formula for it. What is the formula? P naught 2 by P2. What is the formula? 1 plus gamma minus 1 by 2 m2 square to whole power gamma upon gamma minus 1. So you have to calculate this value P naught 2. We know that m2 we have already calculated, it was 6 point, no, m2. Let me check, we have calculated m2 or not. M1 we don't have m2, so we'll calculate m2 also later. Yes, we need to calculate m2. So how to do that? We'll find m2 first. We have formula m2 square is equal to 2 plus gamma minus 1 m1 square divided by 2 gamma m1 square minus gamma minus 1. You calculate m2 first. So once you know the m2 value, then we can get p naught 2 by p2, this formula, and we can find p naught 2. All right. So it's a 0.4, right? It's a 0.4. 0.4. So now use this formula and calculate p naught 2. P naught 2 will be 6.39 atm. Okay. This is the total pressure. Can 6.39 atm. All right. P naught P, P naught 2, which is the total pressure behind the shock. Now total temperature, how to get that? Total temperature. So total temperature, total temperature behind the shock. How to get that? Again the same formula need to use. What is the same formula? P naught 2 by T2 is equal to 1 plus gamma minus 1 by 2 m1, sorry, m2 square. m2 we had seen just now, we had calculated, it was 0.4. Keep this value here. T2 we had calculated, what was the T2? We had calculated T2 is equal to 1860 Kelvin. 1860 Kelvin. Gamma, you know, it is air, 1.4. Keep all the value here. P naught to check how much it is. 19.5 Kelvin. Okay, right. So now almost all the value we have calculated. One more thing you can do, check, calculate T naught 1, calculate total temperature behind the shock. So T naught 1 by T1 is equal to what? 1 plus gamma minus 1 by 2 m1 square. Okay, calculate this. What is the m1? You had calculated how much it cost, 6.2 something, 6.2 0.27 something you had calculated only. Gamma 1.4. T01 calculated temperature T1 you had calculated at 15 kilometer you had calculated 216.5 Kelvin. Now find out what is T01. Quick. It's 1919.5 approximate Kelvin. So take T01 and T02, both are same. This is gate question they are asking also, that value. Total temperature must be constant, and that is the property of normal shock wave also. Check the table I said. Okay, so again I am writing here note. Total temperature. Total temperature, it is also called stagnation temperature. Stagnation temperature must be constant across normal shock. Because stagnation temperature will change when there is the heat addition or heat rejection. We are not adding heat in a normal shock, and we are not taking heat away from normal shock. So that's the reason total temperature is what? Constant. Alright, total temperature will be constant because total temperature will change when we are adding heat or we are rejecting heat from the system. And system is what? Normal shock, and from the normal shock, because it's a very thin layer and we are not adding any heat from out source, and we are not rejecting heat from the system from the normal shock, hence total temperature must be constant. The question they are asking, okay, objective question they are asking, total temperature T1 greater than T2, T02 greater than T01, or T01 is equal to T02. So always remember T01 is equal to T02. Done.